Advanced autonomous AI agents, that's a mouthful, isn't it? Big welcome to my talk. Hopefully this will be what you came for. My name is Andreas Wänqvist. I work for a company called Voyado, actually. This is Microsoft on my tag, not sure why. I'm an AI architect at trade, Microsoft MVP. And I used to work for Microsoft in the Azure division before. Do some open source stuff in the Aurelia core team. Anyone dabbles with web and heard about Aurelia? It's really bright. I see all of you raising your hands. Really cool. Thank you. Thank you. Thank you. So, 2025 is supposed to be the year of the agents. Not sure if we all agree, but we have come so far. We have the tools. We have great base models. We talked about RAG this year and last year a lot. Everyone knows what RAG is? Yes, cool. A lot of AI people in the room. Real-world interactions we got by tools introduced by OpenAI, like late last year, something, middle last year. A way for the LLMs to reach out, orchestrate some logic, and now we got NCPs, and they're all the rave now. Everywhere it's MCP, MCP, MCP. Good unlock to enable our agents to reach out and do even more stuff. So what's an agent? Everyone got their own solid belief and their own truth what an agent is. I don't know, as an industry, if we really collectively have agreed on what it might be. But what we can agree on is that some part is intelligence, inference over them, or machine learning or something. Today we're mostly going to talk about LLM-based agents. They have some agency, otherwise no agency, right? So doing things by invoking code, calling APIs, invoking MCPs, some kind of autonomy, and they run iteratively in a loop until they resolve a task, hopefully. And then I think the biggest contention about what an agent is does it need memory or not? I don't know. Does it? If it's a really small agent that gets started for a task and then just gets destructed when it's done, does it need to remember anything? Could be traumatic, coming back, realizing you haven't been alive for a while. I don't know. They're not that sentient, perhaps. Memory is one of the hard parts, though. So this talk is a bit scattered, because I wanted to show, for those who are new, how to actually build agents, where to get models in Microsoft Foundry, and then also give you, in some kind of short way, like 500 days of developing agentic systems and pain and suffering from that I wanted to give you so that you can take it away. All the hard parts are really hard to make good demos about. So unfortunately, I mostly have to reason and talk about it, because why? LLMs are slightly stochastic. Problems that arrive in systems, as you try to harden your systems, make them better and tweak them, it takes longer and longer in between failures, but when the failures happen, they're often really bad, borderline catastrophic, at least for that agent. So it makes it super hard to do a cool demo, right? Because it might take 2 days. Or, okay, I'm not that good at coding agents, but 2 hours at least until failure, maybe more sometimes. Right? It could take days. So bear with me, and I hope that will fit most of you. Who's started writing agentic systems? Some of you. Who's totally new to writing agentic systems? Oh, cool. I think this will help most of you then. So Microsoft Foundry. Up until last week, it used to be called Azure AI Foundry. This is the meeting place in Azure where everything AI is converging now in the Azure portal. But as you can see, that it doesn't quite look like the Azure portal, picture on the right. If you have any experience with Azure portal, it's because the group feel that they're moving so fast that the portal isn't the right tool for them at the moment. And this screenshot is just a couple of weeks old. And as you can see at the top there, it says Azure AI Foundry, which as of last week has been renamed, and this view is actually being replaced by another portal. So go figure, things move fast in AI, right? But what we're after here is what we need to build our agents, and that is models, and more models, right? We also have some really important things here that we can use, like evals. If you are going to develop agentic systems and put them in production, you need evals. Because LLM-based systems are hard. They can differ. Just upgrade something small in a prompt and your evals will just steer off. They will behave differently from just a sentence, more or less. Change a tool, and everything will change. Upgrade the model, and everything could change. So make sure you have evals in place before you go to production. Tracing, OpenTelemetry tracing is built into agents and workflows that you can build in Foundry, really good, and you can hook that up as well. Also very nice to have when things goes off. Something new, they called agent service, where you can actually build agents and agent-to-agent communication and workflows, and also set up memory for your agents in Foundry if you so please. Deploying models, look, in one of the portals it looked like this. You have a small models and endpoints down here, where you can push this button to deploy your models, and these are deployed models. This model name here is really important, because when you choose model in your code later on, this is what it wants. So remember that if you're going to code agents with Microsoft Agent Framework. Also semantic kernel uses that as well, if you're trying that out. And we're going to supply the agents with the URI and a API key, of course, to be able to get to these models. And there's 3 different tabs here. It's hard to see, but you need the one that says Azure OpenAI, this endpoint. If you use the endpoint from the Foundry one or Services one, it's going to fail. So Microsoft Agent Framework. This is really new. This was released in preview now in October, so it's just, what, 2 months old? Moves fast in the AI. It's a successor to semantic kernel and autogen. Anyone tried semantic kernel or autogen? A couple of you, cool. Yeah. So you don't have to move off from semantic kernel. Maybe you know that, but it is going to still exist, and they say they're going to kind of backport new. If they implement new stuff in agent framework, they're kind of going to keep semantic kernel in sync as well. But I think some of the workflow, larger things are going to stay only in agent framework. And some abstractions like vector database handling, stuff like that, is still going to exist, I think, only in semantic kernel, actually, which is kind of strange, but we'll see. It's still early days in preview, right? Autogen was Microsoft's kind of a research SDK, where the Microsoft Research implemented their latest cool experiments, stuff like that. It was mostly used in Python, I think. Semantic kernel was more the effort to make it more businessy, adding tracing evals, stability, stuff like that, middleware, etc. Agent workflow management is new. That wasn't in semantic kernel. Kind of cool. And it builds on open standards, MCP, as you all heard about, A2A, Google's agent-to-agent interop protocol, Open API, you can use those, just call APIs. And it should be cloud agnostic, which is also good. Although Microsoft Foundry is picking up and getting more and more models, so maybe we don't have the same urge to be totally cloud agnostic now as we did before, perhaps. There are two stupid slides now with all the different agent versions or types that are supported. What this tells me is just that there's too much. We shouldn't really have 2 tables full, but this one, Microsoft Foundry models-based agent, is what we're going to do in code. We're going to look at that in examples. And the upper one, we might have time for a demo, depending on how much time the technical difficulties took in the beginning. Also, if you have questions, just raise your hand, and if I don't see you at the back, just stand up and shout, make a funny dance, tell a neighbor. I will do that as we go. So, constructing an agent. Super simple, just create an Azure Open AI client, and we have models that we have already set up in Foundry, right? So we need to give them the URI, the API key we looked at before, the way it looks in code. Can you see this in the back, or is it too small? Was that a thumbs up? Awesome. You got really good eyes. I need to get a number from your optometrician later, I think. So, yeah, super simple. Here, I did a small helper thingy here because it's super easy to write those strings wrong. But remember what I pointed out the previous slide, right? This is super important to get that right, and that was like the 3rd column. When displaying the tables, right? And create an AI agent, just give it instructions, system prompt, right? Good at telling jokes, tell me a joke about programmers. There's nothing funny about programmers, you're all awesome, it says, of course, yeah. So, memory. Memory is really good to have if you have more than one prompt you wanted to finish, right? Memory is one of the hard part about writing agent-based systems. We have an abstraction handily available here that we get and use, which is called agent thread. You can serialize it and save it if you wish and please, and you can implement custom stores, which means you implement the chat message store abstraction, and you can save to Cosmos or blob storage or pick and choose, whatever you want. So here we have created an agent, and then we just call get agent thread, and we have a thread. And then you see below, we do 2 calls, and we pass in the thread here to both, which means, of course, it remembers what we asked it before. So it can actually tell us what was funny about that joke after actually doing the joke. Tools and functions. So now we're getting into the fun part of agents, right? Making them reach out. In semantic kernel, we used to have classes or methods that we put attributes on, injected that. Here we go for methods mostly. We can use AI function factory create and just send in the method, excuse me, and it will create a tool for us. We also use the description attribute instead of a specific attribute that semantic kernel had to enhance context for the LLMs. So a method could look like that, get the weather, a fake implementation. This could be an API call or whatever, another AI agent, you name it. Descriptions for both the method and the properties that it expects. And why do we do that? Any takers? Because models aren't that smart always, right? They need some help and coaching into what they need to send in for parameters or why they even should use the function. So AI function factory create and the method name goes into the tools array, and we're done. Easy, right? Yes. You can also define agents and use those as tools. Super simple. Or if you have an AI agent, then just use as AI function and send it into the tools array. So here we create a complete agent that has access to the tool we created before, that getWeather method. And then we just take that agent and say as AI function, and that's a tool that other agents can call. So this is a really neat way to Jenga all your agents, separate functionality, agent by agent based, right? Using MCP tools, super simple. Just cast the tools to AI tools and inject it into our agent tool array. So this is a big chunk of code, but all it does is just start up the GitHub MCP server and gets all the tools from it. And all this code is in the repository together with the slides. You'll get the link at the end so you can run everything at home. So you don't have to take notes if you don't want to, because it's all available for you. So this will list all the tools that the MCP client has available. And we just cast them to AI tools, send into the tool array, and bam, we're done. There's also lots of built-in tools in AI Foundry. Some of them are Microsoft native, some are OpenAI tools, and I think we'll only be seeing more third-party things in there, which is cool, in my opinion. Azure AI Search. Anyone used Azure AI Search? 1, 2, nice, good. Maybe I shouldn't cover my face all the time. Sorry, it's just bright lights. Azure AI Search, really nice. Spin up Azure AI Search, dump all your documents into it at your company. And then you can just call it, and it's a vector search, so you can RAG essentially over all your documents that you pass into it. Azure functions, every business has loads of Azure functions, right? You can call those as tools. It can be really handy and use the functionality you already have written. Browser automation, that is OpenAI's browser automation that came out so sometime during this year. I haven't tried it myself. Hopefully it's better than the first demos showed, but I don't know. If you try it, let me know how it goes. Code interpreter, really nice. Some problems like math and plotting graphs and whatever, best way to solve them is by enabling the LLM to write code and execute it to calculate it, especially if you have big data sets. But do you want something to execute code nilly-willy in your systems? No, you prefer it to be sandboxed in Microsoft's environment, right? Deep research, that's one from OpenAI as well. Really nice to have access to that one. You can write it yourself if you have a web spindler and models, write your own agents, but it's kind of a hazard. Not a hazard, but a hassle, sorry. So that one is handy. You have a couple more ones. Grounding with Bing search was just searching with Bing. You used to be able to use the Bing service before to get searches. I built tools using that for search, and that was quite okay. But it got deprecated, I think, in August. So this is what you get now if you want to search and use Microsoft tools. Also, you have one to fetch web pages, I think. Microsoft Fabric is in preview. It's cool. That's where all the data lakes are going to be eventually, right? So you'll be able to access all your company business data. Middleware. Middleware is nice, right, to use for cross-cutting concerns. Billing, logging. Rate limiting is also good. We have access to what's called agent run middleware and function calling middleware, where we can introspect context, the results we get, etc. Do stuff before agents get called, after, before function gets called or after. Also have a chat client middleware, but that's only available for iChat client-based agents if you use those. Looks like this. This is the agent run middleware. You can see we get the agent, get messages, we have the thread, and the AI agent itself here. You can do stuff before, execute it. Also means we can change stuff if we want to, right? So it's cool. You can inject context with the help of these if you want to. Maybe not the best place to do it, but it's possible. And we can log or do something after agent is actually run and return. Same with function. Get the context, agent, do stuff before, run it, do stuff afterwards if you want to. Setting it up is just .use in the agent builder. Super simple. Reason for this one is that for agent run middleware, you can have middleware that handles the non-streaming and the streaming output scenarios. Metacognition. Now it gets fun. Anyone knows what metacognition is? Metacognition is the process of thinking about thinking. So now we're getting deep. This is philosophy. To be able to reason about reasoning, you need to do some form of recall, then reflect, and hopefully adapt to it if you need. So in the case of agents, fetch something or do something, have memory that's connected to it. And then after doing the task, have the agent itself or maybe another agent to revise the output and say, was this good? Was it not good? Did I do or did we do what we were supposed to do or did we not? And then from that, being able to adapt afterwards. And the question is, how do you get them to adapt? Well, for the next run, next cycle, you persist the knowledge of that something was maybe not good, but at least bad. I shouldn't be doing this that I did last time because the output result wasn't good. You can modify the context, alter memory, use tooling, perhaps. This is not super simple, right? But it's really fun to play around with. So one really simple way to handle this is to give it tools for handling users' preferences. So this is just two simple methods for storing and retrieving data. This file is just, or in this case, it's just a file on disk, but it could be a blob, whatever, text. And then the trick is to get the agents to use them. Because just giving, you can see further down, we have given the agent the get user preference, save user preference as tools. It's in the tools array, right? But just because we give the agent tools doesn't mean they always know how to use them. I'd say this is one of the hardest problems building large agentic systems today. You can build superb tools, but actually getting the agents to use them is totally another story, right? So, evolution, spin off to metacognition. How can you make them evolve? Simple ways. Modify the system prompt. So when you spin up an agent, you have a system prompt that's supposed to start it. You get that from blob storage, for example. So you enable the agent to have learning through tools that actually updates the system prompt after it does something good or bad. And then next time it spins up, it loads the system prompt, it has evolved, it has changed. Hopefully for the better. That's kind of the issue here. Getting it to be concise and to do this in a good way, that is not always super simple, to say the least. So how hard can it be? I wrote there. You can see from the big font how frustrated I was when I wrote that. But it's not super simple. I had, depending on what kind of model you have backing this, they have better or not so good understanding of using tools. So I had the system up and running where I allowed the agent to update its system prompt, and I coached it, and at one time it gave me results for transportation up in Stockholm. I told it I live in Linköping, and then when I came back the day afterwards and tried to use the same agent, it did not behave at all as I was used to. It said, you live in Linköping. Yeah, I know that. So I checked the system prompt, and the system prompt was, everything was overwritten, and all it says was the user lives in Linköping. So that was broken after that. Workflows. For when we need more structure in our agentic systems, we turn to workflows. Prior to workflows, we try to chain agents and tools and to get them to behave better by prompting better, right? Now this is another tool in our tool belt where we can actually pass through strict typed values back and forth. And I'd say this is kind of a big unlock. And also, from getting one or two agents to do everything, we divide and conquer, and we can use branches, and we have human interaction parts, and we can integrate to other agents or APIs or whatnot. And we have a clearly defined work order for how the data travels, which is really cool, I think. To build a workflow, they're a combination of what we call executors and edges. We use a workflow builder to wire it up, and executors are processing units, handling typed input, and this means you can define different ways of an executor to handle incoming data depending on what the type of the input is as well, which is really handy. I'll show you an example soon. They produce either a new type, passes it out, or maybe it's some kind of endpoint, then it just produces an event. Edges are what ties all the executors together. We have direct coupling, and we have conditionals we can use, and also fan in and fan out. Also, there's event send. Several events for the workflow are being provided by the framework, and we can also write our own proprietary events if we would like to use that. That's really small. You don't need to see everything it says, but it is. So we're building a workflow here where a writer and a critic is going to work together and passing messages back and forth. And you see the small loop. It's so small you hardly see it, but that is. It loops until a counter has passed a certain value here, and then we exit if they're not done. So, setting up first to chat clients with models, 2 different models here, and then a couple of executors. And then the executor looks like this. We send in the chat client, and in this one we actually set up an agent, give it instructions. You're a skilled writer, blah, blah, blah. And then in it, we have the router. Is that how you pronounce it here in UK? Yes, nods. I passed. Thank you, thank you, thank you. Which handles both. You see, we add a handler for string and also one for critic decision. And string is just prompt from a user. Write me something about this. Will be incoming as a string, but if we get the type critic decision in, then we know that it's from another box in that flow. That was actually critique about what we wrote last time, and we handle that in a different way. So this is handling the prompt. Just send it off, render it, just prompt it. And then this is the type, the critic decision. See, it has structured data here. Was it approved or was it not? Feedback for what to revise. A couple of more fields for iteration, handling the looping thing. And this is the other handler for when we get the critic decision in. See the first type there? And revise this, the following, and send some feedback if you have feedback, otherwise accept. And over to models. You're doing far? Okay so far? I mean, you're doing far, so okay, yeah. People nodding, still awake. Good, 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 good. Models are fun though, aren't they? All the rave. We've been just exited like the most hectic period in LLM AI land since whenever. Have you all gotten to test the latest models? Some few nods. Okay, Gemini 3. How many tested it? 2, 3. Not that many. Do you like it? Good? Bad? Yeah. GPT 5.1 just came out. You tested it? Some had more. Yeah, cool. Like it? Good? Bad? Nods. Anthropic. Opus 4.5. How many tried it? Yeah, about the same. What do you think? Shrugs. It's like the most advanced model ever. Yeah, who cares? Cool. I love it for coding. I think it's really cool. Just as fast as Sonnet used to be, and more brilliant, more better, more awesome, more everything. Yeah. And with that, different models certainly behaves in different ways. And this is really important to know when you're writing agent-based systems, right? Yeah. Oh, big sigh. And the thing is, they're good at different things as well. So it's very much a mix and match scenario here. What I do implore you to do is, if you're going to write agentic systems, break the problems down into smaller parts and try to get agents to work together, then being the agents based on maybe different, hopefully different models that are good at different parts. Okay? So for logic, I updated this slide over the last day, and I still forgot to write GPT 5.1 because that came out previous week as well, right? And putting Gemini 3 there on the row below is maybe it's bad because Gemini 3 is, I'd say, from what we hear, I haven't tried everything, but from what I read in the grapevine, I'd say they're just as good right now, logic-wise. They're really tight on the charts. Grok 4, anyone heard about the Grok models? From XAI? Yeah, Elon's company. They had really, really, really good perf on a lot of eval and tests when it came out. I think most of people who have tried it and building with them kind of concluded that they are not as good as the evals show them to be. I don't know why, but that's the case right now. For tool calling, which is an essential part of some agents you are going to build, are going to be solely based on just calling tools, deciding what tools to call, etc., and when and how many they can handle, and how many successful tool calls you will have will differ with models as well. Right now, there's actually quite a big difference, I'd say, between the Anthropic models. Opus Sonnet HiQ is the smallest one. I haven't written that out, but even though it's their smallest model, it's really good. Oh, sorry. Trying to save Earth here. Apologize. The Google models are also really good. And it seems Grok and GPT-5 are worse. The OpenAI models have been not as good on tool calling as Anthropic models have been during the last year, I'd say. No shame, no blame, it's just the way it goes. I think actually OpenAI themselves limit how many tools you can connect to GPT. If you create an agent in the user interface to like 5 or something, it used to be that way before. Anyone? So GPT Pro, who knows that? No. But that is just because tool confusion. they have a hard time deciding what tool to call, etc. So I showed you an example before with the MCP server for GitHub, right? And that has like 15 tools straight up. And if you want to add more tools, doing something more than just checking out code from GitHub all day, well, then you need models to be able to understand. Token price also differs. Microsoft has a model series they call Phi, which is not an LLM, they call it SLM, small language model. And they are fast, they are efficient, they're more kind of specialized at what they do. They have one flavor for language translation, for example, and other ones. And they are small, fast, and good, and also very cheap. So if those fits any of your scenarios, have a good look at them, because they will suit you well. Google, fairly cheap as well. Then comes XAI. Oh, I shouldn't say Google in front of my phone. And then OpenAI, and last in the series is Anthropic. They've been notoriously expensive compared to the other ones. I haven't written Opus there, but that was like no one used Opus before 4.5 because it was too expensive almost in coding, even though people thought it was really good. It's also not as fast. But now they've changed stuff around, at least with Opus, where it doesn't consume as many tokens as it used to have before. So it's way more token efficient. Oh, please. So it might be worth checking that out. And there's loads of leaderboards, of course, for stats, but this is a good one. It's kind of a summary. So it can be good to check out. And you can also check the various, like I'm going to write something where I need loads of tools. You check the LLM leaderboard for tools, and bam, you have a model you can select. Microsoft Foundry, what is available there? That is all good and fun, I think, as I have a subscription to Foundry. OpenAI, Microsoft owns part of OpenAI, so OpenAI has been available there for a very long time, their models. And now, in cursive, Anthropic and Microsoft signed a deal. So we can actually get Anthropic's Sonnet, Opus, IQ from Foundry as well, which I found really cool. All those agents I wrote that broke, I'm going to try those out with some Anthropic models next and see if their tool calling is better. We can also get the XAI models, the latest ones, and of course the Microsoft Phi series that I talked about. Mistral, French ones. DeepSeek, which is kind of fun, but it's open source, right? So they can spin it up, and they actually have two versions. One where they have kind of circumvented all of the censorship, where you couldn't ask things about certain things that were sensitive. It's really good models, actually. Cohere and Flux. Who's heard of Nano Banana? Yeah, it's been loads to talk about Nano Banana. It's really awesome at handling inpainting, creating new images, stuff like that. If you haven't heard about it, Flux has similar models that are almost as good, and they're available in Foundry. So if you have an Azure subscription, you can use those. If you don't have Gemini, Google subscriptions. And are you awake? Here comes the hard things. Last stretch here. What's the hard thing about writing agent-based systems? Well, as soon as you need memory, that's hard. Because what is memory? What goes into memory? What kind of memory do you need? Do you need only short-term memory? you need to keep the memory stream intact. You only have a certain context window to put stuff in, and that should fit any vital memory that you had, any system prompts, any additional context that comes out from tools. Because you saw those you remember those description attribute strings we slapped on the tools. Well, they all get serialized into JSON schema thingy-magog that gets put into the context as well. So if you have loads of text tools, those will produce loads of text that will be put into the context as well. I think someone said that the GitHub MCP, if you shove everything from that into context memory, it takes up 70K tokens. That is more than the first models a couple of years ago had for total and context window. Right now, many models have a larger context window, but still 70K is a lot. I think some Anthropic models still only have like 100K context window. So be mindful. Context management is super important. Don't overflow, because that will lead to collapse, immediate collapse of functionality. Scratchpad is a good tool, or trick, where you create a tool, call it Scratchpad, saves text to blob or whatever, where the agent itself can continue to update like things it needs to do in the list, or memories I need to keep, where it kind of can discern itself. Tool calling, just talked about that. Context management is super important. Tooling confusion is a thing. If you name your tools like too similar, if the descriptions aren't differing enough, it will just call the wrong tool. And just based on what I've done with the 4.0 and 4.1 models, just getting the agent to use the tools is hard. I can provide the tools, but it still won't use them, right? So I need to often find myself, I have to inject into the system prompt like few shot examples. You have access to the mail tool. You can now read mails. If the user says this, then call this tool and return this in this form. And models. Mixing and matching is often quite good, because I don't know, probably won't have time with that demo, maybe, we'll see. But for the writer-critic example, if you take two models as writer and critic, say you will pick 4.1. It's really fast right now, so I tried it out with that. Almost always, the critic says, looks good to me, it's a pass on the first try. Why? Because they have like the same values. They don't differ as much. If you give one for the writer, say 4 series something, and the critic is 5 series something, sweet Jesus. It's a wall of text with critique, right? Because they don't have the same training, they don't think about it the same way, they're different. They just 2 weeks ago came a super interesting paper about dividing problems between an array of smaller agents and letting them solve the problem together, compared to large, heavy models that was like super good models, the best ones. And it fell out in favor for an array of small agents instead, trying to tackle the problem by dividing and working together. And then one funny thing was how they detected that they were going off the rails. They were instructed to pass results back and forth to each other, the small agents, as JSON. And as soon as one of the agents got the package that was not correct JSON, well, then they knew it was off the rails. They discarded that iteration and then continued. And that worked surprisingly well, which was a fun paper, really cool. Web browsing. So in the beginning, this was a large part of agent-based stuff. We want to check stuff in the web, etc. Parsing web is really expensive if you just, you can hand hack it yourself, build an HTTP client, get me a website, and all the stream. And you know how much JavaScript and pop-ups and everything there is. Sure, the agent can find text within that, but you are going to consume tokens as mad, which is not good. Also, it's being littered with everything. So in most of the cases, we have to fall back to classical engineering. What would we do? Get rid of all the craft, remove the JavaScript, remove all the inline CSS, everything. Better just swap format. Maybe go over to Markdown, because then all of a sudden you have a terser format, you keep the text, you keep the information, but you remove the craft. Thinking like that is a really good way to attacking problems when working with agents. Think agent, yes, but classical engineering combined is the best. Oh. I'm sorry, I didn't know I could run my demo from my clicker. That was not my plan. Sorry. Economy facts. It's also a fun one. I don't know how many friends I have that started coding agents, and then it's like, give me good stocks, please. This is really hard as well, because why? They're trained previously. They have cut-off dates sometime middle year last year, and it's all they are having sound principles, but they're not going to be eager to answer you, because they're kind of told to not answer when it comes to risking people's health, lives, economy, etc. So it's going to be really hard to get them to do anything good for you. In reality, and also we know economy is like what happened yesterday is what rules the market. So what do? Well, we fall back to classical engineering. We have functions calling economy APIs. Get that data in, then we can reason about it. But do be mindful there. It's fun, but it's not lucrative. That's my take on it. Not right now, at least. And beware, up until recently, all models were like totally super bad at math. They couldn't count R's in strawberry even, right? Because, well, yeah, just didn't work. Now we have a couple of models that have like gold medal Olympiads in math, which is mind-blowing. Never thought that 2 years ago. But that is cool. And long-term memory. We talked about memory. Long-term is even worse. If you have a long-running conversation with the user will expect you or the agent it talks to remember stuff. So it's not, you can't only have the short-term memory where it's cut off what you did like the last 50 messages. Maybe the user says, you remember that presentation we worked on 2 weeks ago? Well, that will be long flushed from recent memory. So you need some kind of way to handle long-term memory as well. And then it starts to get, but I'll store more data. Yeah, but which data is the problem? Because there's loads of data being produced here. The function calling as well is producing data for you. So how do you discern what is good? Then you fall back to summarization is a good trick. We can summarize things that aren't like super important. And after a while, you will need to start to weight it, right? How important is this data? Temporal weight. User asked for email yesterday. Is that relevant? No. The user has probably gotten more emails, might have deleted half the emails. I need to get the emails again. Temporal weight. Contextual weight. What is important, what is not important. Saying hi to the agent every day might not be as important as getting a plane ticket booked, for example. Like, it's hard. And if you take anything with you from this talk at all, then it must be that the presenter was really funny and I shouldn't change the model. As I told you before, the changing like stuff in a prompt or just something in a function, or heavens forbid, you get function results back that change and you don't know what has changed, but the text getting inserted into your context from the tool is kind of changing the behavior. Anyone see the keynote will think prompt injection, right? Even worse is if you have something that is working and your colleague comes and said, did you see that this model got updated to 6.2 yesterday? Could we try that? Yes, and you enter it, and you send off to production. Well, that's when you're happy that you have evals, right? Remember that funny guy told us to create evals, and now we have that, because the chance that your system kind of changes totally is really, really high. And I'm sorry, I was hoping to do a couple of demos for you, but it's in the code, it's in the repository, you can pull it down, and if you just set up your Azure Foundry, as I showed you, get the URI and the API key, you can run it yourself. Call me on LinkedIn, I'll help you if it doesn't work. And there you have slides and LinkedIn. Or not only slides, code as well. So connect with me on LinkedIn, and we'll talk agents and AI and everything else that's fun. Or just clone the repository and play with it and start creating agents. That's all for me, I think. Thank you very much. Thank you.